Bismillahirrahmanirrahim. Assalamu alaikum. Now we are talking about unit number 6, the first part of the unit number 6, which is starting with the dimensional analysis. In this unit, we have three different topics. So the first topic is the dimensional analysis. Dimensions. Dimensions are what actually, for example, we measure the distance in meter, feet, centimeter. These are the units, and the dimension for the distance is length. Similarly, for mass, we measure the mass in the kilogram, gram, slugs. So these are the units for the mass, and the dimension for the mass is m. So dimension analysis is a method which actually helpful for us to analyze some physical phenomena. For example, the distance formula S equals to VT, and that formula is actually helping us to yani find out uh, the relationship between this parameter. The S equals to V multiply by 2E. So you see that the S, the unit and the dimension of the S is the length. Distance is length. Velocity is length over time. And the time is again the T. So the T time will cancel here. You will get the distance in term of the length. And here also you have the same dimension. So the dimension analysis actually check the any physical phenomena happening, and it is satisfying the condition on both side or not. So we will see how we can understand this concept one by one. Let us see that basic units in the dimension analysis are the length, mass, and the time. So these three dimension actually covers all the physical phenomena which we need to discuss and explain. So for example, if I want to find out the dimension of the velocity, or I want to do the analysis on the velocity formula, so what I have to do, the velocity, I know this is the distance per unit time. So again, the distance is here and time is here in this phenomena. The density is mass per unit volume. The dimension mass is there, and the volume is actually length cube. So that again the length is here. So this is the dimension of the density. This is the dimension of the velocity. Like that, we can have the all the dimensions of various physical quantities in terms of the length, mass, and time. So this will be helpful for us to understand any physical phenomenon. For example, the basic physical quantities are the mass, length, time, temperature, area, all these things having the dimension. Mass can be represented by m, length as l, the time as t, temperature also, and the area, like it is areas, for example, for a rectangle, length into the width. So the dimension will be L square. The volume will be L cube, three dimensions. As I told you, the velocity is the length per unit time. Similarly, the acceleration, length per unit time square. So these are the dimension for various physical quantities. So these quantities can be utilized to solve various physical phenomena, which we will see in the coming slides. So these are the derived units, for example, momentum, force, pressure, specific weight, etc. If you put the unit of them, you can find out the dimension. You use the dimension, basic unit dimension, the MLT system, then you can find out the dimension of all these quantities. So the just for example, the density is mass per unit volume, right? And how you will put this dimension? M over L cube, because L cube is the volume. Momentum, okay, momentum is what? The mass into velocity. So the mass is m, velocity is length per unit time. L t raised to power minus 1 mean L over t. So this is for the mass and this is for the velocity. So like this you can get the dimension of any derived property by using the basic dimension, again the MLT system, mass, length, and time. Again, these are the further most commonly used physical quantities: the work, energy, power, torque, all this having the dimension based on the MLT system. Well, if we want to utilize these information uh, to satisfy, to check the any physical quantity or physical equation, then we have to use the dimension homogeneity. We have to check the dimension homogeneity of a system. What does it mean? If both sides of an equation, for example, you have an equation, if the both sides of an equation indicate the same physical quantity, the dimension of the left hand side of the equation must be equal to the dimension of the right hand side of the equation. So it means that whatever the dimension you have at the left hand side, it should be equals to the dimension at the left hand side. Let me show you this how you can do that. For example, we have this equation as we discussed that the P equals to gamma h. So the P, what is the dimension of the P? You know, the what is the P? It is the pressure, Newton per meter square, right? So the Newton is force, and force is mass into acceleration, right? And acceleration, what is the unit of the acceleration? Length per unit time square, right? So this is all the dimension on the left hand side. Let us see here. What is gamma? Gamma is the Newton per meter cube. What is the Newton? Again, the force. This is mass into L, okay, Newton, mass into acceleration. You get how you are, I'm writing this one, because we know that Newton is the unit of the force. And how you can define the force? Force equals to m into a, right? So the units of the mass is this one, unit of the acceleration is this one. Same thing I put here, right? Because the pressure is the force per unit area. So this is the force and the area L square. So the left hand side we get this one, and this side this one, the mass into this one. So gamma over L cube. This whole thing is what? This is gamma. Again, what is gamma? Is Newton per meter cube. So the Newton is the, according to the force, the m L over T square, right? Per unit volume in L cube. So this is gamma, and H is L, right? So this L will cancel out, it will be square, right? And this one, when you will simplify, what it will become? L square will cancel this one, right? So you will get m over L T square, right? Here also this L, right, this will be cancelled out, so you will get m over L T square. So you see that both sides having the same dimension. So in this way you can check any equation by using just the dimension. Don't put the units like the meter and centimeter or feet. Put the dimension m, L and T. There is nothing more other than the MLT. So once you will simplify, you will see that the left hand side will be equals to the right hand side. So this is the check for any physical quantity, and that will explain that this relationship is correct or wrong. So in this way you can utilize this dimensional analysis. So any equation you can check from the dimensional homogeneity, and that can be done by utilizing the different dimension. So these quantities also you can do the same thing. The momentum, use that same dimension, that use this formula and check that what is the dimension of each these ones. So here actually you have to just find out the dimension. How you will this is here energy, work, all these formulas there. Just put the basic unit and you see what is the quantity of the these physical quantities, what is the dimension of these physical quantities. So this you can find out from basic dimension. For example, if we want to check the dimension homogeneity, we have to use the same thing which I have done in the this slide. And how you will check the dimensional compatibility and homogeneity? By using the basic dimension on both sides. Then you can get this value. So now, for example, this one, in this question, the v is the velocity. So just put the L over T here. This is constant value having no dimension. So leave it. In the under root, you will get the 2. So 2 have no dimension. Forget about this. G is length per T square, L over T square. H is the, again, the L. So the L and L will cancel out. So you will get the length over time square, right? Length square over time square. Under root will cancel the squares. So you will get on both sides the L over T. So that will be compatible. So you can do any equation for the dimensional homogeneity check, and you can find out the both sides are same. If it is same, then it is a homogeneous equation. If it is not same on both sides, it means it is a non-homogeneous equation. So this is all about the dimension analysis. uh, Dimension analysis can be done for a complicated equation like any empirical equation, and any physical phenomena can be explained by developing some equation. For example, any formula like the Manning formula, you remember the Chezy formula, those formula developed by doing the experimental studies, and based on that you find out, for example, the velocity is proportional to the area of the channel, the velocity is proportional to the hydraulic radius, the velocity proportional to the slope of the channel. So once you know that the dependency of one parameter on the other, you can develop that formula. So the Manning formula, Chezy formula developed based on these studies. Here in this section we want to see how we can develop various formula for different physical quantities and physical phenomena. So dimension analysis by initial methods and by Buckingham Pi theorem are very common to use. So these are the two methods which are used for dimension analysis to derive some formula for physical relationship. For example, this question, I have already given you the solution of this question. Let us read this question and what it is saying. In a pendulum, the frequency of the pendulum per unit time, how many cycle it is completing, and the unit of the frequency will be 1 over time, per unit time only, number of cycle per unit time. So this frequency is the function of the length. How more length, then it will change the frequency. And the value of the gravity also is changing the frequency. So the frequency of this pendulum is depending on the length of the pendulum and force of gravity. If we know the dependency, we have to determine a formula for this frequency. So we have to drive a formula. We have to develop a formula which can describe this physical phenomena. So this is the application of this concept. Let us see. uh, if, for example, I have I have already put this in your uh, blackboard. This one, the question. The same question, there is a pendulum and we have to derive the formula for this physical phenomena. So what we have to do, you can see that the frequency f is proportional to the length and the gravity. Let me make it a little bigger. I hope it is visible to you. So 1 minute, it is too much. Anyway, so the frequency of this pendulum is depending on the length and the gravity. So this is the frequency is a function of length and the gravity. You can write this formula in this form: F equals to C, depending on the length, depending on the acceleration. So because we don't know how much it is depending on the length and how much it is depending on the gravity, so we put power A and B to see the effect of all these parameters, the length and the gravity. So this is the starting point of this question. So I know the dependency, I make a formula like this one. C is a proportionality constant which appears when we put equals to here. Now you can see that the dimension of each. What is the dimension of frequency? 1 over time. So 1 over t, the length is L raised to power 1. Power 1 mean it is same. The acceleration due to gravity is length over time square. So you see L t raised to power minus 2. Now we have the dimension of all this thing. So let me put these values here in this formula. C is a constant. There is no dimension for this one, so it disappear. C will disappear. So I get this equation. Now I simplify this equation. So L raised to power will become A, right? Because 1A, and L raised to power will become B, and T raised to power will become minus 2B, right? Now I have this equation. At this step, I will apply the MLT system for both sides. For example, in this side, there is no M. So I will just put M raised to power 0, because any power 0 mean it is 1, right? There is no L, there is no length, so L raised to power 0. The t, yes, it is t is here, t raised to power minus 1. So this is the left hand side. Let us see this side. There is no m again, so m raised to power 0. There is L, yeah, L raised to power 1a and L raised to power b. So I put L raised to power 1a and L raised to power b. Time, yeah, there is t raised to power minus 2b. Okay. Now I want to see uh, independently for m, L and t what is the equations are here. M raised to power 0 here, M raised to power 0 here. This M raised to power 0, M raised to power 0. It means there is no equation for M, because M raised to power 0, M raised to power 0, no meaning. It is 1 equals to 1. So forget about this. L raised to power 0, L raised to power 1a, L raised to power b. So I can say that L raised to power 0 equals to L raised to power 1a, L raised to power b. So for both sides, I equate the value of the L. I just put value of L in this form. Same thing with the t. Here t raised to minus 1, here t raised to minus 2b. So this is another equation. So I have this equation, and this equation doesn't exist. If in some question there is m also, then we will get three equation. Here we get one equation, one equation, this one. Now our objective, what we are going to do? We actually are interested in the powers. What is the value of a and b? Because here in the beginning, we assume that L having the power A and G having the power B, in order to find out the effect of L and G, how much is it depending, right? You remember in the Chezy formula, the V equals to C under root R and S, and R having the power of half and S having the power of half, right? So how this power half came? This actually I want to see how much will be the power of L and G in the final formula. So we are interested in finding the value of A and B. So now I have these two equations. So I just make the further equation of only power. Here the power is 1, here power is minus 2b. So I will get minus 1 equals to minus 2b. And from this simplification, I get the value of the b 1 upon 2. If I make the equation from here also, so 0 equals to 1a plus b, right? So 0 equals to 1a plus b. So this equation I get. So when I simplify this one, I can get the value of a, right, which is equals to minus b, right? You get 1a mean a. So when b will be at the other side, so a will be equals to minus b, and b having the value of half, I put half here. So I get the value of the b also. So in this, by using this equation, I get the value of a and b, which actually I am looking for in this formula. Now once I get this value, I just put in this formula, this equation, right? L raised to power half, G raised to power half. So this is my formula for the pendulum F equals to C G over L and 1 over 2. So by this is my actually final step. I don't need to go further. So this is my formula which I want to drive. So this is the application of this procedure, right? We, as I told you, we can use the diesel method, which we just use in this example, and Buckingham Pi theorem. So the indicial method which we solve this problem is based on that indicial method we solve, and we find out the formula for this physical phenomena. Let us see another example. I also uploaded this problem also. The example 6.3 is talking about the force acting on a propeller of an aircraft, and the fan of that aircraft, which is rotating, and the the force of this propeller is depending upon the variables, the velocity of the propeller, the dynamic viscosity, the mass density, the diameter of the propeller, and the speed of the rotation of the propeller. So we know that these are the parameters on which this force is depending. So I have to determine the formula for the force. Same way, like here we develop the formula for the frequency for the pendulum, which is depending on the length and the g, and we've got the formula, right? F equals to c under root l into g, right? So this formula we got for this problem. So similarly we have to get the formula for the force, right? Let us see what I have given you. The solution which I have given you, you can see here. So this is the same formula. So we know that from the question, the force is a function of the velocity, the dynamic viscosity, the density, and the diameter of the propeller, and the number of the rotation. So this is the first equation. The next step, what we have to do, we have to remove this the dependability, the relationship, and we put a constant. You can put c or k, whatever, and we put the power on each a, b, c, d. Like in the previous problem, we put the l raised to power a and g raised to power b. So I put a, b, c, d, e. So this is my equation a. Now I have to develop the formula for this f. Again, I have to apply the MLT system on both sides. There is this is force, right? The force, what is the unit of dimension of the force? You remember, this is ml over t square. The mass into acceleration, acceleration l t minus 2, length per unit time square. So this is the dimension of f. What is the dimension of the v? Length per unit time, right? So I put here, so, and this mu also, the for density, all this dimension, the diameter is l, number of the rotation per unit time, t raised to minus 1. I just put the dimension of every quantity here. Now once I get this equation, right, and there is a power for everybody, every term. So what I have to do, from this I can simplify this equation in terms of the power. I just directly put this the equation of MLT. What you can do in one more step, you can separate this. M raised to power 1 equals to M raised to power B, M raised to power C, okay, right? So you will get the equation for M is 1 equals to B plus C. Here, what is the power of M? 1. At this side, M, what is the power of M? B into 1, right? Because B is the power of M. So M raised to power B. So I put B here. Here also M raised to power C. So power C is here. So these are the equation of the powers for MLT system. After simplifying, I get the value of the B in term of C. Same thing for the L. This L having power 1 here at left hand side. So 1 is L raised to power A. So A is here, right? L raised to power minus B. So minus B is here. Again, L raised to power, this is uh, minus, this is the minus 3. So what will be C into minus 3, minus 3C, right? Here L is power D, so D is here. So now I have equation of the powers for the L system. Now I have this equation also. I have this equation also. When I use the t raised to power minus 2, t raised to power a, t raised to power minus b, and the t raised to power minus e, I get this another equation. So for MLT system, we will always get three equations. The problem in this question, there are a, B, C, D, E. There are five unknowns, and we have three equation. And you know that if you have unknown more than the number of equation, you cannot solve the values. You cannot find the value of the A, B, C, D, right? If there are three unknown and three equation, you can find the value in terms of the constant numbers, numerical values. Like in the previous question, we get the value of the A and B 1 over 2. So what we can do this question in a way that we can find out the value of A, B, and C, three values based on three equation in terms of D and E. A value of A, B, and C in terms of D and E, or any three value in terms of any other two values. It's up to us. So let me, I solved this for value of A, B, and C in terms of the D and E. So I have to just simplify these three equation. and I have to find out the value of the A, B, and C in term of D and E. So what I did, first of all, to find out the A, B, C, D in term of the D and E, I use the equation number 2. This is the equation number 2. I find out the value of the A. Okay, I just shifted the value the other side, and then I put the value of B from here. I put this value, I simplified this, I got another equation, right? The A in term of the C and D, right? Now, equation 3, we have the equation 3, this one. From here, I can again find out the value of A, right? So I simplify this. Again, I know that the value of B is 1 minus C. I put this one here. After simplification, I get this value. Now, this is value of A, this is value of A. I compare this two value equation 4 and 5. I get this equation. And after simplification, I get the value of the D equals to minus 1 minus c minus e. Now you can see that the value of the d is in term of the c and e. So from here I can find the value of the c, because I need the value of a, b, and c in term of de. So I get the value of c in term of d and e. Now I got the value of c. I put this in equation number 4, because here I can put this one and I will get the value of A in term of the these two unknown D and E. So after simplification, again I got the value of A in term of these two parameters. Every value A, B, and C I need in term of the D and E, no any other parameter. So here we get in term of D and E, here we get in term of D and E, and again when we put this value into the other equation, then we after simplification we get the value of the b in term of the d and e. It's up to you how to solve. It's just algebra. Just you have to substitute the value from any value from this equation to this or this and to this. You will ultimately find out the value of a, b, and c in term of the d and e. Once you get this value, just again plug back this value here, right? In term of here a, b, c, d, e. Once you put these values here, a, b, c, d, and in equation number a, this is equation number a, I got the value of a, this is the b, this is c, and d and e as it is. Just my answer is here. This is my answer. But in order to give a simplified form, what I did, I expand these values, and v raised to a, v raised to 3d, and 2e, all these I expand. Then I put the same values together, and after simplification I got this equation. So this is the final equation of this propeller, in which the force is proportional to all this parameter, 5 parameter, and this is the final formula. So this is the way to solve this kind of the problem, and this method is indicial method, which is helping us to find out the formula for any property. Same thing is in this question 6.4, exactly the same steps you have to follow. The only thing, what are the dimension you have to use here. It is talking about efficiency and the density, the dynamic viscosity, the velocity, angular velocity, and the diameter d. This also I already gave you, so just you have just go over this problem which I have submitted already. The solution is there, just check this one, then in the same way you will find out the finally the formula like this one. So you will start from all this parameter, putting the constant a, b, c, the power as a, b, c, d, and e. Simplify in the same way, make the equation, simplify putting value from one equation to another, get the values of the a, b, c in terms of d and e, and you can find out this formula. So this is the application of the indicial method, right? So uh, this is all about the first part of this unit. If you face any problem, anything in understanding, let me know. In the second part I will explain further about the remaining, which is the models and similitude. So we will talk in the second part. Thank you. Assalamu alaikum.